before I begin. So the first thing I recommend you do is write things in terms of sine and cosine. Okay? Remember that if you multiply sisters, so sisters I mean sine and cosecant, cosine and secant, tangent and cotangent, it's always going to equal 1. Does anyone want to take a guess why that is? Why do you think when you multiply sisters you get 1? Tamaya? They're similar, and the word I'm thinking for begins with an R. I don't think anybody reciprocal. Look at Marquand, boy. They're reciprocals. Anytime you multiply reciprocals, you get 1. So for example, 4 over 5 times 5 over 4 is 1. 3 times 1 over 3, 1. A sine times a cosecant, 1. Because they're reciprocals. Now, can everybody please take out your pink paper? Because that pink paper is going to be very, very, very important. And if you don't have it, we have some extras over there. Feel free to grab one. I want you to look on that pink paper where it says Pythagorean identities and variations of the Pythagorean identity. So it's on the front side, so the other side. And I want you to look for where it says Pythagorean identities. There's 3. And then I also want you to look at where it says variations. Put a big star or circle those 2 sections. You need to have those memorized. So when I say look for an identity, that's what I'm talking about. So you need to have those 7 identities memorized before our skills check, which is coming up next week, and our next test is on March 18th. All right, that side will not be given to you on the test. The other side of the paper will be, but not that front side. So everything on that front side you need to know. Okay? All right, so let's go ahead and jump in. We're going to do one at a time. So I only want you to copy down the first example here where it says simplify. And we're going to take cotangent and divide that by cosecant. So simplify. There's 2 different types here. There's simplifying and verifying. When you simplify, you don't know where we're trying to go. It's kind of weird. But when you verify, if you look at your homework, if you look at numbers 4 through on, you see how it tells you what we're trying to get to? That's called a verification. You're verifying what we know the answer is. But for 1, 2, and 3, we don't know the answer. All right, so does everybody have the first one copied down? All right, so let's go ahead and rewrite. Step number 1, rewrite this in terms of sine and cosine. So let's talk about the numerator. Cotangent. Cotangent is what? In terms of sine and cosine. I know it's A. Okay, so in terms of sine and cosine. Cosine over sine. So cotangent is cosine theta over sine theta. And we know a fraction means division, so I'm going to write that as division. All right, now we also have cosecant. What is cosecant in terms of sine and cosine? So how would I write that? 1 over sine. Cosecant is 1 over sine. So now let's go back to when you learn how to divide fractions in 4th grade. How do you divide 2 fractions? Keep, change, flip. Let's do that. Keep the first one. Change to multiplication. And flip. What do you think is going to happen now? What's going to cancel out? The sine. Good job. And I'm left with a cosine. That is my final answer. With simplifying, you just keep going until you run out of things you can do. Once I get down to cosine, there is nothing else I can do. That's it. I'm done. That's my answer. So going back to the helpful hints, rewrite things in terms of sine and cosine. And then you have to know your fraction rules. All right, let's look at number 2. That one should go fast. Take a minute and copy that down.
Wait, so for this one, you have to find identities or that?
No, this one didn't use an identity. I mean, yeah, no, it didn't. It didn't use it. Not this one. Now, this is the helpful hint, the second helpful hint that I gave you, which says when you multiply sisters, you get what? 1. Do you agree that secant and cosine are sisters?
No.
They are sisters. They got the same mom and daddy. That's disrespectful. They're sisters. So here, secant can be written as 1 over cosine. And when I multiply that by cosine, what's going to happen with the cosines? They cancel, and that's why your answer is simply 1, because that cancels. All right, last one. Go ahead and copy this down, and I want you to try, because number 1 is very close. Number 3, sorry, is very close to number 1, so I want you to try to do number 3 by yourself. So rewrite it in terms of sine and cosine. Do your keep change flip. Thumbs up if you got an answer. This one should go fast. What y'all get? Sine. Let's do it real quick. All right, so we have our tangent. Tangent is sine over cosine. And that's divided by secant. And secant is 1 over cosine. We do our keep change flip. Keep change flip. The cosines cancel out. And that is how we end with a sine. And we hit a spot where there's nothing else you can do. And it's like in the beginning is going to be rough. I'm not even going to lie. But the more you do it, I mean, the questions are pretty much recycled. It's the same questions. I think the hardest part is coming up with the processes. All right, Miss K is going to do the next 2.
Yes. I'm not irrelevant yet. Yes. Okay. Okay. Copy it down. Copy it down. You guys seen the Judge Judy TikTok that's like ding-a-ling-a-ling-a-ling? No. You know what I'm talking about? Yeah. I feel like that's like this entire unit where it's like your bells should be going off the entire time. Where it's like, oh my God, like I've seen that before. So, does anyone recognize sine squared x plus cosine squared x as anything they've ever seen? Oh my gosh, Tamaya says yes. Anybody else?
Yeah.
Okay, CJ says yes.
Yes. I believe so.
Okay, this is an identity. It's the special identity that we had to know even on this last test. It's the Pythagorean identity. What is sine squared x plus cosine squared x equivalent to? 1. So then we didn't do anything with the cosine, so we have 1 over cosine. 1 over cosine is what? Secant. Boom. Look at how easy that was.
It's like magic.
Check.
It was magic. It was magic. You're right.
Would I be kind of wrong if I didn't put the theta mark?
Okay, so your x's, your thetas, in this next page we got some betas. All of it is just a variable. You can change all of them to x's, all of them to thetas, whatever variable is working best for you. So this next one, yeah, this should have been x's on top and x's on bottom. We're just gonna, when we wrote this originally. So this is a, oh, cosine x. Anyways, sine x plus tan x over 1 plus secant x. There's a lot going on in that problem, okay? We got addition on the top, addition on the bottom. We still got it like some fraction stuff going on. So what we're going to do is we're going to break it down. We're going to start with the denominator. So you're literally going to go and you're going to write denominator. And you're going to rewrite it exactly as you see it. No, it's not the denominator, it's the numerator. But we can start with the denominator. Let's start with the denominator. 1 plus secant x. Josiah says, I can write the secant in terms of cosine. So let's do that. We got a 1 plus 1 over cosine x. That's the same identity we've been dealing with since the dinosaurs roamed the earth. Now, this is kind of as simple as we could get it, but we're still adding basically two fractions and we don't have them under one denominator right now. So I think, me personally, that we should multiply it by cosine x, this 1. So that it can be a cosine x over a cosine x, so that these two fractions can be combined. When we say that it's going to be difficult at the beginning, this is what we mean. Because you kind of have to just like make it up for a little bit, try to see how far down the line you can go until you can't make it any simpler. So by multiplying 1 by cosine x, we end up with a cosine x plus 1 all over, now both this fraction and that fraction both have a cosine x on the bottom. Okay. So the last question I asked before we move on to the numerator. Ouch. Okay. Does anyone agree with Jaden that those cancel?
Yeah.
Whoa! There's cosine x plus 1 and a cosine x with no plus 1. If there's an addition somewhere and they're not the exact same thing. Okay. So that's as simple as we can make it. We made it one fraction, we combined all the parts, we did the thing. Now to move on to the numerator. You can kind of do it, if you want to do the numerator first, that might be Simpler for you, whatever works, but that's just what we're gonna do. So we had sine x plus tangent x. Sine x is already written in terms of sine or cosine. Tangent, how can we rewrite that in terms of sine or cosine? Uh-huh. Uh-huh. Sine x is not currently a fraction, but it is. There's always a little imaginary 1 down there. So right now, we have a denominator of 1 and a denominator of cosine x. So in order for them to have like denominators, we're going to multiply this left fraction again by cosine x. So we end up with a cosine x sine x plus a sine x from this fraction over here. And then our two fractions have the same denominator. However, do we think this is as simple as we can make it? No. We see on this top portion, both of these have a sine x in them. So we're going to pull the sine x out. So if we were to pull the sine x out, it's basically like undoing a distribution moment. So we're going to put a sine x on the outside. When I pull a sine x out of the first term, what do I leave myself with? Cosine x. When I pull a sine out of the second term, what do I get left with? If it was nothing, it wouldn't exist. 0 kind of trumps everything. So that's why whenever we pull it out, we get left with a 1. And then we didn't do anything to the bottom. Now, do you think that we can make this section over here any simpler? No, I would agree. So, that's great. We have these two like super simple things. But our original problem was the numerator over the denominator. So, let's write them together. So we got make sure that you write it in the correct order. I know we did it out of order. It's the sine x multiplied by the cosine x plus 1 over cosine x divided by a cosine x plus 1 over cosine x. Take a minute or 30 seconds. Whoa. And go ahead and try to figure this out for yourself. Okay, Jaden. And Osmo. Bunch of smarty pants. Yeah.
Did you pull the sine x out from right here?
Yes.
We got
Mhm.
okay.
Because then if you were to undo this, it would go back to looking like that.
Oh,
Yeah. Okay. Oh, I see so many correct answers.
yes.
Okay. So, when you keep change flip, you keep the first fraction, you flip the sign, or no, change the sign and flip the second fraction. So, for sure, everyone knew that these two things canceled out, right? The reason we can cancel cos x plus 1 out is because now it's by multiplication, not just addition. Because this is like one whole term here. And this one whole term also appears here. So that's why we get to go bow, bow. So at the end of the day, you get left with just a sine x. Okay. Back to Miss Bryant.
All right, y'all, next example. Again, we'll just focus on one at a time because I'm not sure how much space it'll take. So we'll just do one at a time. Yes, so I would probably start with the top. So let's just start off with this top, the numerator. Oh, wait, did you say equals 1? Oh, but they're not being multiplied. See, I follow you. I see what you're saying. They're being added, not multiplied, okay? Multiplying fractions, adding fractions, different. So let's rewrite this in terms of sine and cosine. Tangent is sine over cosine. I'm only doing the numerator right now. So tangent is sine over cosine. Cotangent is cosine over sine. So let's just go over here. Let's just say that you are adding these two fractions, right? We don't have a common denominator, so I would multiply this one by what? What would you multiply this fraction by? By 2. And then what would you multiply this fraction by? By 3. We're going to do the same thing. I'm going to multiply this first fraction, top and bottom, by sine. The second fraction, top and bottom, by cosine. So when you go across the numerator, so my denominator is just sine times cosine. So now let's go across the numerator. You have sine times sine. And what is sine times sine? Sine squared. Good. Plus cosine times cosine, which is what? Now, hopefully, you're recognizing something in the top. That's one of the most used identities. What is sine squared plus cosine equal to? 1. So we've gotten as far as we can go with that. So I have 1 over sine cosine. All right, I'm dividing that by cosecant. Cosecant squared can be written as 1 over sine squared, because that's what cosecant is. Now let's do your keep, change, flip. Keep, change. Now I'm going to rewrite sine squared as sine times sine, because I want you all to realize that that's what we really have there. We have 2 signs at the top. A sine squared is a sine times sine. And because we're multiplying, we can't cancel. What can I cancel? What cancels out? Yeah, just one of the signs. And when you multiply across, I'm left with 1 times sine over cosine times 1. So I'm left with a sine over a cosine, which is what? What is sine divided by cosine? What trig identity is sine divided by cosine? And that would be your final answer. All right, last one for today. You said you think these are easier?
I said, it's a whole way.
Yeah. All right, copy this one down.
So you have to write a whole paragraph to get that.
Whew, complaining.
Now she can do better and be.
What did I say while I was up there?
Oh,
Those are all just different variables.
Yeah, if you want to, you can change these to an X. These are notes, that were generated a long time ago. So they'll have different, no, not generated, but they'll have different Greek letters in there, like theta, alpha, beta. But you can change them to a regular old boring X if you want to. That's fine. All right, so we need a common denominator again. So I'm going to multiply this fraction top and bottom by 1 plus cosine. So I'm multiplying this fraction top and bottom because you have to have a common denominator to add fractions. Period, point blank. And so this other fraction I'm multiplying by 1 minus cosine. So my denominator is 1 plus cosine times 1 minus cosine. We'll deal with that in a second. So we need to distribute. So if I take the 1 and multiply it by 1, 1 times 1 is 1. 1 times cosine is cosine. Bring down the addition sign. Do the same thing over here. 1 times 1 is 1. 1 times negative cosine is negative cosine. Okay, what's going to cancel out at this point? In the numerator. You think anything is going to go away? I think you said it, CJ. What'd you say? What'd you say? Yeah, right. In the numerator. Do any of these terms cancel out? The cosine. See, because one of them is positive and one is negative, so they're going to cancel. So you're just left with 1 plus 1, which is 2. All right, so here, this is where if you know the pattern to multiply binomials, it's going to save you a lot of time. However, if you don't know it, then make your box and do it the old-fashioned way. We need to multiply our denominators so we can get 1. Go ahead and multiply that. This is the difference of squares, by the way, going back to Algebra 1. So you might recognize what it is, but if not, just go the long way. It's okay. So when I fill in my boxes, I have 1 times 1, which is 1. 1 times cosine is just cosine. 1 times negative cosine is negative cosine. Negative cosine times positive cosine is negative cosine squared. So this is going to cancel. So my denominator that I'm going to have left is 1 minus cosine squared, which you probably used. Does anybody know? If you don't know, look at the pink sheet. What does 1 minus cosine squared equal? You had to use it maybe on the test yesterday. Sine squared. So I'm going to change this to a sine squared. So those 7 identities, if you need flashcards, 7 flashcards, let's get it now. I know a lot of us pouting about that test yesterday, so we need to lock in on this next one. Let's get those 7 index cards and start memorizing these identities. I'm not done because this is kind of ugly to leave a fraction. So anytime you have a fraction, whatever you have downstairs, you can always move it upstairs. But when you move it upstairs, it changes to the sister. Okay? Who is the sister to sine squared? Who? Cosecant. So I'm going to move that sine squared up, and it's going to be 2 times cosecant squared x. Now we have finished and made it to the end. So use this time. I want you to try to do the homework. Just try. Number 3 is the easiest one because it has an identity. Even though the sine and cosine are not next to each other, it still equals 1. Okay. So I think 3 is the easiest homework. I would probably start with that.